Okay, it's almost ready. Here we go. Hello, everyone. Welcome to our second showcase. It's almost ready. Here we go. Sorry. All right. So, welcome to the Bayer Group Apprenticeship Showcase. This is the second one. We had one yesterday, and today we are focusing on engineering and design in product development. And so we're so proud to be working with Downey Unified, Davis Joint Unified, as well as Glendale Unified with their high school students. Some of them have graduated. Many are juniors in high school right now, and they have been participating in a 8-week paid apprenticeship. And so we have been working with industry leads who have been hosting deep dives. And so I'm going to turn it over to the deep dive lead, Andrew Lario, who is going to introduce his apprentices, and they're each going to showcase for us today. Hi, Andrew.
Hey, how you doing, June? Thank you so much.
Good, thank you.
Yeah, I'm not going to take too much time to introduce this. It was engineering and design and product development. I have, worked with a lot of different groups for this, and you never get really a sense of what the team is going to be when you start getting together and the personalities and different talents, come out. And I was particularly impressed with this group. They worked incredibly well together. Given the online format of this, they had to collaborate and work kind of in a self-directed way, asynchronously. And given the time constraints and everything else, they really performed well. They really attended to everything. And, I was just really thankful to have an opportunity to work with them. And with that being said, I just want to turn it over to them and give them an opportunity to showcase what they've done and share some of the amazing work that they've been up to. So bring up the slides. Okay, so we're going to begin with the first group. They did a lot of different projects that are currently in development in my organization. And each group took on a different project, and we're going to start with the first one, which was developing a trail cam.
Hello, everyone. We're Trail Camera Group 2, and our project was an underwater reef monitor. My name is Delia.
My name is Hassan.
My name is Jaden.
My name is Anish.
My name is Sophia.
Hello, my name is Brandon.
You can go to the next slide.
We're going to start with the project overview. Our aim is to create a camera deployment, housing, and monitoring system to retrieve data for the Blue Dot Artificial Reef. We're going to start by talking about the reef project itself. The Blue Dot Artificial Reef is an artificial reef that's 10 feet deep and 100 yards offshore. The picture you can see below in the bottom left is the actual reef, and Blue Dot wants to photograph the reef with their camera design. Blue Dot created the reef by having elementary students create clay molds, which highlights how Blue Dot works to aid their community. We'll talk about our motivation. Our motivation in this project is to create a functioning underwater camera system to photograph Blue Dot's artificial reef and to foster advanced learning in environmental areas.
For our initial research, we decided to split up the work and discuss what we found for our field camera. We researched development, communication, and the housing for the camera. Then we came together, talked about our goals for the field camera.
For the group divisions, for our project, we divided into two groups, being the tech leads and the engineering leads. The engineering leads use Onshape to design a housing system for the camera, and the tech leads use the Arduino simulators to test a working camera circuit. We decided to go into these groups based on interest and also experience. Some people had more experience than others, so we devised a buddy system to help each other.
Now we're going to talk about individual experiences. Jaden and I assumed the roles of engineering leads, as well as Brandon, for this project. We focused primarily on the intricate task of designing the housing for the camera system. Our motivation behind this choice was to expand their skills and knowledge in crafting various types of housings.
Okay, yeah. So Hassan and I were the engineering leads of this project. we had the privilege of leading the development of our innovative underwater camera housing system, ensuring every aspect of its design and construction met our exacting standards. First, we created a sophisticated CAD model on Onshape and conducted thorough research to select optimal materials. Our design features included a sturdy support structure and a secure camera mounting system tailored to enhance performance within the aquatic environments. And then alongside this, throughout the development of our underwater camera housing system, we incorporated several innovative features, which included rolling rubber strips on the base for enhanced grip, a solar light attachment for extended operation, and the custom weight attachment for precise buoyancy control. Additionally, we designed a simple dome that can easily be bolted in and out, providing effortless access to the camera. Each of these elements was thoughtfully integrated to ensure both functionality and ease of use in underwater environments. Our efforts in developing this underwater camera system was instrumental in creating a viable product as it allowed for the camera to operate at its full potential. Allowing the camera to capture high quality images and video with clarity and precision was something we were successfully able to try and accomplish. And then this project was underscored the significance of practical application and hands-on experience in translating theoretical knowledge into real-world solutions. And it has prepared us to tackle challenges creatively and effectively, equipping us with the confidence to pursue a career in engineering or a related field.
I chose this challenge just out of curiosity in engineering, and I just wanted to see what it was like. I played the role of a tech lead, but I looked into the deployment of the camera, and we ended up accomplishing like where we should put the camera in the coral reef. And the takeaway is that the challenges that we had to face online instead of working in person.
I was drawn to this challenge because I think that reef monitoring is important to ensure our ecosystem is healthy, and developing an easy way to do that is important. I was drawn to the underwater location because I thought that the challenge of accessibility and the fact that we have to create an airtight system would be a fun challenge to overcome. I assumed the role of project manager, which meant I led discussions, I assigned tasks to our group, and I managed our deadlines so that we were on time with all of our all of our work. I also represented the group to our deep dive. I also assumed the role of technical lead, which meant I researched the Arduino system and I ran Arduino simulators for the camera circuit board. I also ordered the circuit boards and assembled the physical prototype. Finally, I helped develop a code to run the motion sensor camera system. I then assembled the physical system and we're working on testing the prototype. This allowed us to test the capabilities of it, assembling it. My takeaways were that I had a lot of firsthand engineering experience and I got to learn about the engineering process. I learned how to use the Arduino circuit board simulators, and I had a little bit of Onshape experience. Finally, this helped me learn time management and also goal setting skills, and I also learned a lot about leadership and collaboration with the team.
I chose this challenge because the main reason was because I wanted more practice and I wanted to work more with circuits because I'm interested in circuitry and electrical type engineering. The work I spearheaded or I took on was mainly the simulations. So getting the Arduino simulations to work with our circuits and our different sensors. This ended up being successful as we had two simulations, which we'll show you later. Both of them ended up working, and so this helped a lot in our final prototype design being made and our final circuit board being completed. And this then which we'll deploy in the Blue Dot Reef. This helps me for my college and career goals because one day I want to major in electrical engineering and want to become an electrical engineer. And so getting this early practice with circuits and early training is going to help a lot in the long run. And one big takeaway for me for this apprenticeship is I learned a lot about the engineering process and the steps that happen in the real world of designing a product to it becoming a finished product.
I chose this challenge because I think I was more interested in this because I've never worked with cameras and also just anything underwater. My role was an engineering lead. And I helped come up with some some ideas of the 3D designs. This it just connects overall because it just helps with the overall design of the actual project. Some takeaways I have is that I do want to become some sort of engineering, mainly mechanical engineering in the future. And I think any engineering based experience helps with that. This overall, this apprenticeship has shown me what it might be like to actually have an engineering job in the future, and also helps me work more in groups and being able to adapt to different environments.
So these are two simulations that we had for our Arduino circuit board. So the simulation on the left is we are testing the PIR sensor with an LED because unfortunately the camera that we use, the ArduCam, that model isn't in the Arduino simulation. So we had to use the LED instead to test to see if we could figure out how to get the PIR sensor to light up the LED. And then the simulation on the right, for our communications method and data storage, we went with a micro SD card. And so we were testing to see if with the PIR sensor, we'll be able to capture data with a micro SD card reader. And then on the right hand side is all our code. No one in our group has major code experience, so we did have to use the help of AI to get our code to actually create a code since we don't have that kind of experience. But luckily, the code that we were able to get was successful and it did help both simulations run.
All right, after we tested these simulations, we actually ordered the physical parts and I was able to assemble the circuit board system at home. This is just an image of what I have so far. We haven't done our testing, but we know that it turns on. And this model is exactly what we did in the simulators. It just has all the components together with the ArduCam instead of the LED light. So you can see at the top, I labeled everything, but there's a USB port. There's a USB-B port connected to the Arduino, which allows us to input all our code. And the Arduino is what connects to all of our sensors. So the ArduCam is down at the bottom right. The breadboard connects all the wires because we don't have enough pinholes. There's a micro SD card module, which is where the micro SD card will be held and all of our images will be stored in the micro SD card. We have our power source, which is the 9-volt battery, which connects to the Arduino and powers it. And then finally, we have the motion sensor, which will be located at the top of the dome and will sense when any organisms pass by the dome so that it triggers the ArduCam to take a picture.
All right, and then on the top left, you can see the dome. Unfortunately, we had to order it off of Amazon because we would have had like visibility issues with the 3D printer. But yeah, we were able to get that, and we're trying to make it soon. And then on the bottom left, we also have the base, which will be 3D printed by our deep dive lead, and will work hand in hand with the dome to create a successful housing system. And then the technical drawing you see highlights the view for the entire housing system and like the cost of every material, which shows how each product will be manufactured or ordered online. And then you can see that we have 8 legs on our housing system right here. And this was driven mainly for stability and to like go past turbulent underwater conditions. And then also you can see that little compartment below the dome. That's where we would like to add weights, like maybe concrete, to like prevent the entire system from rolling or becoming unstable.
For our challenges in this project, one big one was time management. Since our apprenticeship is only 8 weeks long, and the amount of time we spent with our deep dives was even shorter, and the amount of when we started this project was even less than that, it made doing the entire engineering process a bit of a struggle, and as well as being on Zoom, so being remote from each other instead of being in person face to face, also made it a bigger challenge to actually make our final product. However, even with that, we were able to complete and eventually make a prototype. Our lack of experience as well, although some of us do know how to use things like Onshape or have worked with circuits before, the main thing is we have never coded before and we never done something on this scale of a product from the start to finish. But in the end, we were able to create a final prototype, which you saw earlier. And in our next steps, we have already assembled it. So now we just need to upload code onto it and eventually ship it back. And after we get the housing printed, put the two compartments together, the prototype and the housing, and then we hope to deploy it in the reef and start collecting data.
All right, so we wanted to give a final thank you to our incredible deep dive lead, Andrew Lorario, whose positive attitude and constant support enabled us to get this far in our project and accomplish our design goals. So thank you so much. Finally, we've reached the end of our presentation, so thank you so much for listening. And if you have any questions, we would love to answer them now. All right, thank you guys.
That was incredible. Thank you so much for that. I just want to welcome in the skate group.
Hello, we were the skate group, and I'm Ernesto.
Hi, I'm Henry.
I'm Saned.
Okay, so the overview for this project is that we aim to create a mini skateboard so that kids can have fun at home, basically. We want kids to be able to have fun anywhere, from their living room to their bedroom, outside, inside, basically anywhere. That way they can express themselves creatively. Through this product, we will help kids further express their creativity, and through these fingerboards, they can customize them, build them themselves, and overall just have a creative experience.
Hello. So, one of the things that I did for this group was I designed the board models that actually ended up being used as the sort of example board kit. It's the model that was used is in the top right corner. It's the blue board, and then underneath it, those are basically the molds that were 3D printed, and then they were used to basically press the boards of the skateboard together in order to get that sort of shape. And the reason that I chose this project was because I had an interest in sort of making things, and the idea of creating something that could be used by a community, right, a school or some sort of after school program for people was really interesting because I hadn't really done something like that before. The things that I had made in the past were kind of for personal reasons or just an entirely different purpose. So the idea of being able to make something that other people will be able to use and be able to have fun with was something that was really appealing to me. And just the overall experience taught me how important it was to continually collaborate and keep in communication with my other group mates so that things would be on track and people weren't, a little confused about kind of what our status was in the moment. And just overall presentation, because the board that ended up being created, the one I designed, was not the only board that was designed in the group. So we kind of had to figure out which board that we wanted to use. So it's kind of like, presenting, this is the board that I wanted. This is the reasons why I think this works best. And eventually all these skills that I learned from learning how to design the board and working with my group allowed me to kind of create my own thing. For me personally, I was interested in kind of making whistles that you can use in situations for emergency. And they were able to be modeled, and I was able to ask our deep dive lead, Mr. Andrew Lorario, to be able to 3D print them. So these are the results here on the bottom right. So they came out, I think, pretty good in my opinion.
Why don't you invent something that's already been invented?
Okay, so what I came up with, or I was mostly the marketing / creative thinker of this group. So I would come up with ideas, I'd talk to my team, I'd make questions. And the reason I chose to do the skate is because as someone who does skate, this is something like very personal to me and very close to me. So as you can see, I have like one of the pictures is one of the things I came up with. It's like a little rampart, a little tech type type of board, so I decided to CAD or ThinkCAD and create my own little like stairs, my own little ramps, my own little pyramids. Um, because of like this engineering apprenticeship, I decided to engineer my own little ramps, my own little CADs, and all that. I came up with some of the ideas as seen like on these images, and I brainstormed all these ideas, hoping that we can make it for our final kit. The skills I learned is to talk aloud with all my group members. As someone who's like sometimes shy, like meeting new like people, this helped me like speak aloud and like figure out problems, communicate with my team.
Hello. I was the project manager. I kept track of the designs and the final work. I was interested in being a leadership role because I wanted to see if I could keep track of everything and uh be on my creative side and know how to do everything. Um, most skills that I learned was how to be a collaborative a partner and learn teamwork. I made good ideas. I helped make ideas with my partners, and I did communicate well as a team with my partners. I chose I chose this lead and this job because I wanted to see how creative I can get with skateboards, and I've learned how to skateboard before, but I'm not good at it. But so I wanted to try something that I could actually kind of be good at. So yeah.
So overall, we were able to get a board made. These are the kind of results of the board here on the left. It's a pretty small thing. It's like a fingerboard. And so we got our board, and we also figured out what sort of part pieces that we would like to also include with the boards so that people can, you know, mess around with them when they finish actually creating the board itself. And also the type of grip tape that we wanted to include for the boards. In this case, probably ones of most likely of different color and different design for customization purposes. Yeah. In the future, if this sort of idea was to be expanded on, some of the things that we would like to kind of continue developing on is basically figuring out how to make the truck holes. They're basically these holes that are used to hold like the wheels to the board, right? So they can roll around. At the moment, it's kind of difficult to send a whole like entire tool to whatever group is going to be making these boards. So we need to figure out basically how these people can do it themselves without needing to send them an additional sort of item. We also would like to plan out basically how we're going to package this whole thing. You know, we want to figure out how big these containers are going to be and how many skateboards you can make, right? So we can figure out how many of these sort of packages that we need to send, depending on how many people are interested in sort of making these skateboards. And also, um, we will also want to be looking into creating some sort of physical manual or some sort of video where so that these people can basically follow along if they're stuck or they need to figure out, you know, how to put the molds together or basically just how to set things up, just kind of general stuff. Um, so that, you know, they kind of have an idea of how things are supposed to go together. Thank you.
All right, thank you so much, Skate Team. I really appreciated all the work that you guys did there. And now the PPL stands for Popsicle Propulsion Labs. This is another kit for learning where popsicle sticks are used to create different vehicles. And I'll allow this group to explain it more. I'm excited to hear this.
Isabella, Lily, Angel.
Hi. So I'm
I was a part of the Popsicle Stick Lab, and I'm Lily.
Seems they're
So
having
the
a little.
design,
Sorry, I'm sorry. Go ahead. I thought you guys were having some connection issues.
no, sorry. Okay. So the design challenge and reasoning. The goal of our design was to create something and build an RC car that little kids and little children in general would be able to make using a kit and a guide that's provided. So we're mainly for anyone looking to dive into the real world of engineering through vehicle design and electrical circuitry. This will be a good design challenge to build. So I was specifically in charge of the design and vision of this car, and our goal was to design an RC car that others can build together. And the way we designed this car, after considering that this RC car is supposed to be constructed together by children, we came up with an easy way to build this car that allows the builder to express their own creativity. Due to this, we decided to 3D print the base of the car, as popsicle sticks are not easy to manipulate, such as the part that connects to the wheels. The actual popsicle sticks would be used for the front and top of the car, and the wheels would be mini rubber wheels provided inside the kit. In terms of the RC car's power, we would provide a motor and battery to power the car and a receiver circuit board to connect the control. And in terms of actually constructing the kit, we decided to provide a visual manual similar to the ones provided with Legos, since we thought it would be the easiest way to understand how to construct the car. Why I chose this is because I have a younger brother who loves RC cars, and he has maybe like 100 of them. So I always see him playing around with them, and I thought it would be something to make and something that little kids can enjoy to make. My role was specifically as the designer of the car and to help create the kits, like the guides that are similar to the Lego ones. The work we accomplished was simply designing the car using something called ThinkerPad, and it allowed for us to make a 3D design on an online platform. And we all learned how to communicate and get along on something that's not really normal for us, like get along over Zoom, which is what we've been doing. But I think we came up with a pretty good design for an RC car, and we were happy with our results. And takeaways in relation to college. So it helped me to learn how to efficiently work in a team and accomplish something over Zoom. So I had a really fun time.
Hi, I'm Isabella, and I chose this challenge because when I was looking at the designs, I was really intrigued by the car design, and I was curious on how to build one, so I wanted to work on this project. The role I had was a marketing lead, which is designing the kits for others to use, getting a list of all the materials, and designing the packages, the artwork, and developing a cost for the kits. The work I accomplished was I started to design and make the material kit list for the RC car that was needed. The work connect for my so what I did, so my role was basically the main part of what everyone needs to start building the RC car, because you don't have the kit, then you don't have the materials needed, and that's really important because that's basically making the whole RC project car. And some takeaways I had from this experience was learning how to build and put things together to create something cool like the RC car, and to learn about the different ways you could research everything you need. Some takeaways from my career goals is that maybe I would want to be an engineer. My dad's an engineer. My brother's going into his first year of college as an engineer in civil engineering. So I think engineering has run in my family quite a bit. So I'm deciding whether I want to be an engineer. If not, then I take a different path. But I think this was like a good way for me to present and see if I wanted to be an engineer.
So it seems as though Angel was having some connectivity issues. So we can maybe circle back in a little bit. I'm going to move on to the next slide.
So what we finished was designing the RC car. Unfortunately, we did not get to actually make a 3D version of this, but we do have a 3D version online, not in person, obviously. And our next steps would be to focus on creating the guides for these kits and packaging these kits and planning how to send them out. I would like to give a special thanks to Baya Group for allowing us to get this opportunity and for us to explore something that we don't necessarily do in school. And I think I had a really fun time. And I'd also like to thank our mentor, Andrew Laro, for assisting us and guiding us and kind of just being there for us to ask any questions to. So I'd like to thank everyone. Thank you.
All right, thank you. We're going to move on to the Rocket Group now. So I'm excited to hear what the Rocket Group had put together.
So my name is Chris. Wait, am I the only one in my group that's here?
Yes, Emilio and Fabian, they got caught up. So if you would like to just do a quick overview, and Zoe had sent in a video that we can watch as well. So in terms of in person, if you could just run through the quick overview, and then we'll watch Zoe's video as well.
All right, that's fine. Anyways, basically what our team is basically making is fun little rockets or air compressed rockets just for fun and learning. That's mostly what they're for. As you can see right here, we don't have much to show besides the package design, and that's it mostly.
Zoe had sent in a video. We can watch that on the next page.
Hi, I'm Zoe Ray. I just joined the Rocket Project Group because I wanted to learn how rockets work, and I also wanted to explore the role of graphic design, which is why I chose the role of designing the guide for the rocket. So I first researched what made a good guide, especially what a good guide looks like for elementary school students. So I used Canva to create a template to the right. And currently I'm revising this template and also working on a second draft to try to make a guide that's a little bit more visually and easier for elementary students. And the guide is important because without the guide, students would have a hard time assembling the project. And this deep dive taught me really how to collaborate with others and the importance of communicating my thoughts, questions, and kind of experience as fast as possible so that we can get our work done. Hi, I'm Zoe Wang.
Now I'll answer a few questions. Why did I choose this challenge? Good reason, just because I want just want to learn more about mechanical engineering. Mostly that's it. What role I have, I already told you in the beginning. I'm a package designer. What I showed you right now is what I've made so far. And I already showed you what I've accomplished. How does this connect to my team's effort? Basically, I'm helping them give a box to put their art design and put all the stuff in. And then take away for my career goal, like I said, helps with mechanical engineering. And well, where it goes with my apprenticeship mostly goes with teamwork and workplace effort.
All right, thank you, Rocket Group. We're going to move on to the High Altitude Balloon Group now. I'm looking forward to hearing what you guys have put together.
Okay. Hello, everyone. My name is Rosalie Whithouse, and what my team worked on for the past 6 weeks was designing a platform for a high-altitude balloon, also known as a weather balloon, and I'll let the rest of my team introduce themselves.
Hello, my name is Jasmine Leon, and I'm the engineering lead.
My name is Matthew, and I'm the tech lead. My name is Winchi, and I'm also a tech lead.
My name is Casey, and I'm the engineering.
And then we can go into the next slide. And I'm also the project manager.
So for our project, we were tasked to design a stable high-altitude balloon platform that can support data collectors. So the platform is what is like a container or of things that is attached to the balloon that we can send out to the edge of the atmosphere. And there were several challenges with this. First, we need to have cameras. We need to have a GPS tracker that can be contained in it. And also we need to have a chamber where we can send in items for possibly an experiment. And there are also some regulations, like it had to be less than 5 pounds and relatively stable.
Blue Dot Education needs a customizable platform to explore the atmosphere and to run experiments with. And as Wenchi mentioned, we had to design a platform that would be attached to a high altitude balloon, and that would need to be able to withstand extreme atmospheric conditions. And it would also need to be able to hold different experiments ran by different people. And pretty much it.
As tech lead, I needed to find the materials that we need to build this high altitude balloon. So I saw that we needed some lightweight aluminum so that it's able to lift off the ground, a GPS tracker so we can monitor it wherever it's going, a power supply to give each electrical component enough power for the duration it's in the sky, a parachute so we can get on the ground safely, a wide angle lens camera so we could have a 360 view of what it sees in the sky, a temperature, pressure, and humidity sensor, so that we can see everything, all the data that's in the sky, and a weather balloon so that it could actually be lifted off the ground, and a testing chamber to store objects.
Okay, so here's our product. I designed it using a 3D modeling platform called Onshape, which I know some other groups have also used. So these are just a few pictures of the final product that we made. The first one is a picture of the right side of it. So it has an indent where we can put a camera that'll probably be a GoPro because that's what's worked in the past, and then also a GPS tracker as well as a thermometer or something to check the temperature and pressure. Then the second picture is just of the other side of it. Well, all the other sides of it basically. So there's one side that has like the big indent and the other sides are just completely flat. So it makes just a regular box. Then the third picture here is a top-down view where you can kind of see the indented part for the camera that'll go on the inside. The fourth picture is just a picture of the basic bottom of it. And then the last two are just like 3D views where you can still see like the indentation where the inside camera will go and then where the materials that we need for the outside camera. And basically we use this kind of model because it has the chamber, which we can do different experiments of things in high altitude, but it also has an outside area to monitor what's around us. Okay, and then we'll move on to the individual experience. So our whole team is just going to answer both of these questions. So why did I choose this project? I chose this project because I'm really interested in going into like engineering, and I thought this project would help me like with 3D modeling, which I haven't really done before. So I thought this would be a good project to like use those skills. And then what are my main takeaways and like things that I learned? I learned a lot about 3D modeling and also how to work in a team over Zoom. I think it was really difficult to work with like a team to build something over Zoom, but we got through it, and I'm very grateful to everybody in the team for working so hard and collaborating really well over Zoom. So yeah.
So the reason why I chose this project is because I think having the opportunity to launch the high altitude balloon into space and collect data from it it sounded interesting to do. And I feel like since space is something I would like to work with in the future, I thought that this would be a good way to start off with. And some takeaways I've gotten from this project is the ability to manage complex projects. And I feel like this project can open doors for me career-wise, such as aerospace engineering, which is something I would like to do in the future.
I chose this project because I wanted to learn the technology behind gathering atmospheric data. And some takeaways I had was I want to be an engineer, so I got to learn the process of actually creating something. And I got to learn how to communicate with the team, especially online. And I got to learn that it's not that hard to actually do this. You just takes a lot of prep to actually launch a weather balloon in the sky.
I chose this project because I've always been interested in engineering and outer space. So when I saw a project that had kind of both, like it went up to the atmosphere, I just thought it was a perfect opportunity to get a chance to practice both of those things. Since I am really interested in pursuing engineering in the future, this just all fell right together. And my main takeaways from this project was that I got to strengthen my design skills and my communication skills since, like Rosalie mentioned, it was difficult through Zoom. So it was just really nice to practice both.
So I originally chose this deep dive because I'm like a creative person. I like to make things. And specifically, I chose to work on the high altitude balloon project because of its focus on exploring the edges of the atmosphere. So it's kind of like the others have said earlier, a mash between my physics, chemistry, nerdy side, and also my more creative, hands-on side. And I think this project really was the best choice for me. And similarly to others, I think one of the biggest challenges that I faced, not just for our group, but for all groups, was the fact that we were not in person. It was not easy to keep focused. It was really easy for everyone to slack off. So we all had to keep each other accountable and plan our tasks and have good time management. And I'm just really grateful for this experience to learn about like how we can collaborate together and also all of the presentations that Bea Group has done for us. And I just feel like I've learned so much.
After designing the payload, we gather all the materials we need. Then we continue checking our design for any flaws, actually build the payload out of the aluminum, and then we prep everything for launch, like weather checks and actually assembling the balloon. And then after we prep, we actually launch it, collect the data, and then recover the balloon wherever it lands, and report and document our final results that we got from the atmosphere.
Okay, and this is our last slide. Thank you to Bea Group for giving us this opportunity in general and working with them. And a special thanks to our deep dive lead, Andrew, for helping and supporting us throughout this whole project. And we'll take any questions that anyone has. Okay, thank you guys.
All right, thank you so much. Thank you. All right, so the next group is another trail cam group. I'm excited to hear from this group as well.
All right, hello everyone. We are Trailcam Team 1. We worked on a land trailcam. I'm Rohan.
I'm Wanjun.
And I'm Elias Garcia.
Next slide, please. So our project was centered around Blue Dot's outdoor learning projects, which they want to support learning in environmental areas and work in natural spaces outdoors. So one of their needs was trail cams to monitor wildlife, and they wanted us to make a trail cam that was autonomous and able to be deployed in the site and some way to store and transmit and recover the data that's collected. So we wanted to design a camera to study animals in the desert area because they're a pretty remote area and we normally don't see much documentation of animals out there. So we thought that'd be an interesting task to take up on. And we wanted to have video capture and night vision features so we could get a constant recording of their activities and be able to do studies from that. So we wanted to create a camera system to monitor animal wildlife in the Anza Borrego Desert down near San Diego. So we can collect data for those animals and do some studies based on that. And we split our design process into different roles based on the different components of the camera system. And we always had weekly meetings to discuss ideas and check progress to keep each other accountable for our specific tasks.
All right, so I'm Wanjun, and my role was designing a housing for the trail camera, and I wanted to attempt using 3D design tools such as Yagi or something to create a protection for the camera. And the role for housing, I created a 3D model for protecting a internal hardware such as camera, main board, and also I wanted to provide a protection for them from physical impacts and some humidity. And I used open source 3D designs from Yagi, and I learned how to cooperate to discuss the design process planning with other group mates. And I ultimately learned how to establish a basis for creating my design, and I actually reused I reused designs from the internet.
So my task was to work on the camera design, and I wanted to do this because I was interested in learning how cameras are even designed in the first place and just the general process of developing and engineering a product. So I was able to design a hardware component system for the camera, and this included a Raspberry Pi microcomputer and a compatible camera. And the camera pictured at the right here already has built-in night vision features, so that made it easy to just have that camera with all the features and a solar battery pack. This would make powering the system very simple because there's obviously a lot of sunlight in the desert, and the battery pack could just directly connect to the microcomputer and directly power the camera. And I brought this together with other design parts that my teammates made, and together we were able to make a prototype for our product. And I gained a lot of experience working in a team to develop a product and learn that process, and also learning how to make a camera because that was just a cool, interesting part of this that I enjoyed. And I also got an idea of what a real world engineering job is like because that's one of the fields I'm considering. So this was a great preview to get that.
So, my individual experience, I was in charge of the communication data transfer. The slide before. Whoa. I have. Maybe you need to refresh it. I can just read it off of mine if you. There you go. So what my goal was wanting to see the communication system, learning how cameras can upload information and video through big areas and multiple areas sometimes. It allowed me to learn a lot about the inner workings of a camera, more the data transfer side of the camera. So my job was to research the different methods of transferring data, whether it was cellular data or Wi-Fi. For our trial cam, Wi-Fi would be a little bit difficult since it would take place in the desert and it's very hard to get Wi-Fi out there. So cellular data was the one I chose. And this experience taught me a lot about deadlines, communication, what it means to be a team. We didn't really have too much time to work on this. And compared to the other trail cam team, it was only 3 of us in this group. So a lot of the time we were a lot more and we had to help each other out a lot. But it worked, and I think it taught us all how to be team players.
All right. In conclusion, we designed models for hardware components such as housing and camera system hardware, including camera, uh, and mainboard communication, and we set up a framework for the data communication. For the next steps, we're going to assemble the system by building them, and we'll probably have to code them because we didn't work on fully coding it. And finally, we will deploy the assembled system in Anza Borrego Desert near San Diego. Thank you to Mr. Andrew Lilario, for valuable support in this project, and Bayer Group for facilitating this opportunity. Thank you.
All right, and our last group is another group that focused on data collection in natural environments, and they're looking at soil monitors, and I'm excited to hear from them.
Good morning. We're a part of the Engineering and Product Design Deep Dive, and today we're presenting our soil monitor, which we have worked over the course of this apprenticeship. My name is Michael, and I'm a tech lead.
My name is Jana, I'm a researcher.
My name is Anna, and I'm the program manager.
My name is Matthew, and I was an engineering lead.
My name is Adrian, I was the engineering lead.
So basically, to start off, a soil monitor is a tool that it's used to measure like the moisture content in the soil, and its purpose is to mainly portray to us and ensure that plants receive the right amount of water. And then there are a couple of different ways that the soil monitor is important to us, and one of them is water conservation, because once we measure the soil moisture, farmers, gardeners, or anyone who's taking care of plants can avoid overwatering, which helps conserve water and reduce water costs. Also, another source is to prevent water stress, environmental impact, and there's also to optimize irrigation, because knowing the precise moisture levels, it allows for like efficient irrigation scheduling, which when the plants receive the right amount of water, they thrive and they grow healthier and yield higher impacts.
Okay, so our group's vision was to reconstruct agriculture and environmental management through modern soil monitoring technology. Many Native American cultures have historically had a deep understanding and respect for their land. Their traditional knowledge often includes advanced methods of observing soil health. We aim to empower farmers, researchers, and conservationists with high-tech, actionable insights into soil health and its understanding, promote sustainable practices, optimize crop yields, and preserve natural ecosystems for future generations.
Our product design. As we mentioned before, we wanted to build a soil monitor that uses renewable energy and can send data digitally or with the Wi-Fi connection. Through our research, we found that the best parts to use for our soil monitor were an 18,650 battery, an 8,650 battery holder, a D1 Mini, a capacitive soil moisture sensor, a TP4056 charge controller, a DC jack, an LED indicator, and solar panels. We would start by 3D printing the moisture soil main body, the moisture soil, sorry, the moisture sensor cover, and the moisture sensor battery cover, and then connecting the parts as seen in this image on the right side of the screen. We only got as far as compiling the best components and how we would put them together, but our next step would be to build a prototype and see how
The group actively communicated during the creation process with group calls during personal time and breakout rooms. To complete the work, we divided the work into two groups. Tech and engineering leads, with the engineering group designing the soil monitors, such as the design and the code for the soil monitors chip, while the tech group researched the purpose and use of soil monitors. During these roles, we faced challenges such as technical issues involving the creation of a brand new code for the chip and the soil monitor. In in short, in the short time frame given, which is a challenge that we were able to overcome.
My individual experience for why did I choose this challenge was because my dad owns a ranch and he's been talking to me about how he needs to figure out the moisture and figure out the right conditions to grow his plants, which provide money for us. And it really interested me into helping him, into trying to help him any way I can with this ranch. And the role I took was tech 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 lead. And it was because I'm really interested in tech. It's one of the areas I'm trying to prosper and trying to grow into. And for college is what I'm thinking of doing. And uh that is and my takeaways from this experience in relation to college and career goals is that it provides me a good work ethic to finish deadlines and to help my team achieve our goals. And my competencies that I have developed during this apprenticeship was that I learned teamwork and I learned how to take a leadership role in our group so we could achieve our goals.
So, my group and I chose this challenge because soil monitors are like very, at first I didn't know what a soil monitor was, but after like researching, it's very important for our plants' health and especially those who take interest in gardening and watering plants and like those who like love flowers. Um, the role I had was to research the basic uh purpose of the soil monitor, which basically it is to enhance the irrigation efficiency by accurately measuring the soil monitor levels and the moisture. And then it's extremely important because, like we said before, it helps to like conserve water and prevent water stress in plants and helps them grow in a healthy and easy way. My takeaways from this experience is to just when a role is given to just do your job, research, and you will do your job, research, and to just make sure that you're educated on the topic so you know what you're talking about. And then the competencies that I've developed during this apprenticeship would be to be a better speaker and to know how to collaboratively work as a team and not just individually. Thank you.
Alright, I chose this project because I was very fascinated to find out what a soil monitor even was. I wanted to find out like how it works and the components behind it. My role in this group was creating a vision for our team through setting goals and planning how these goals would be met in the short amount of time that we had. Takeaway from this experience in relation to college and career goals is I was really able to better my teamwork skills. I really worked on fitting roles with my group in order to progress towards our goals. Um, Competencies I developed in this apprenticeship would be learning new ways to go around certain problems, which is problem solving.
I personally chose this challenge because I was interested in creating something that would help other people. Before this project, I had never heard of soil monitors, so I wanted to learn more about them, and it was interesting for me to understand how one works and how to build a more efficient one. I had the role of program manager in my team, so I made sure we were following deadlines and staying on top of our work. Since I was also a tech lead, I researched possible ways to build a soil monitor using renewable energy and how to upload the data virtually. I want to be an engineer, so this project has given me valuable experience in how to research, how to make a product design, and also strengthen my collaborative skills. Finally, this apprenticeship has helped me to develop timeliness, collaboration, and communication skills. When working to design our soil monitor, we had to submit and we had deadlines to meet, which helped me with the timeliness competency. I also strengthened my collaboration and communication skills by working with my team and with our deep dive lead.
I chose a challenge as I have an interest around crops and plants in general, and I also have interest in engineering, so I thought, why not one with both? I spearheaded the I was a engineering lead, and I spearheaded the research on the components that we need, such as the solar panel, the chips, and anything else we needed, such as the sensor modules. And my takeaway from this experience was, I guess, the experience of working in a group with a solid time lead and time frame in which we have to collaborate towards a goal with such limited communication. And the competency I've developed during this apprenticeship is uh, working with the team.
All right. Thank you guys so much for that. Again, I was really impressed with all the work that you guys had done, and I really enjoyed listening to those presentations. They all came together so quickly, and we have an opportunity to sit down and kind of like take a look at it all. You know, you feel a little celebratory, and thank you for sharing. There was one person, Emilio, that was part of the a group that didn't have a chance to go earlier, was having some connection issues. So I just wanted to give a little bit of time so Emilio could present some of his work.
Thank you, Andrew. Hello, my name is Emilio Becerra, and basically for the rocket project, I was the designer of, as you saw for Chris, he designed the box, but I was the one who's going to design the design of it, and I wasn't able to put the idea in my head on anything yet because I tried and I had technical issues and I couldn't use the website. But the idea I had basically was it would be like a space theme, the box. So it'd be like purple, black, kind of like a Milky Way around the box and the packaging. And on the front, on the top, before you open it to see the whole rocket that you can build and everything, which Chris provided. Um, it would be like a rocket ship blasting into space, astronauts around the box, and like a little stick man riding the rocket, waving like a cowboy hat. Sadly, sorry, I could not provide you with anything visual because I couldn't get it on any website for me to share it with Andrew. But that was basically the entire design idea I had for the packaging for the rocket. Thank you, everyone.
Thank you, Emilio. And I know that you and I had many discussions throughout this time, and you had shared some of your work with me. So we can continue to connect about trying to upload that into a digital format. But thank you.
All right. Was that everybody, Andrew?
Yes, that was every group. Yes.
Congratulations. Are there any questions? Did we have a chance to? I'm not sure. We have someone, I'm gonna go to the YouTube real quick and see if there's any questions. Let's see. And I'm looking at the group. Congratulations, everyone, for your showcase. Thank you for sharing with us what you've been working on. I'm just curious how, well, how do you feel now? You've done it. You've done the showcase. We're going to have a celebration next week. We look forward to seeing you in person. We're going to be in 3 different communities next week doing our celebration. So we're excited to get to hang out with you all. And Andrew's going to be able to come to one. So you'll get to see him in person. You might have seen him. He actually came to our pre-apprenticeship event that we did. So anyways, does anyone have anything else you want to share with us? Are there any questions, Sandy, that we had on?
Not in the chat yet, and not
Okay.
on the live stream yet.
Yes, it was really great to hear. Some of you learned something new. Some of you went deeper into something that you had interest in. Is there anything else that you want to add before we end this live stream that you didn't get a chance to say?
I'll add just like like arching theme that presented itself throughout the entirety of the apprenticeship was their willingness just to kind of like trust themselves and step into kind of uncomfortable spaces. And I think in the design and engineering space, oftentimes, like if you're coming from a school, you might be thinking and waiting for being told what to do and how to do it. Oftentimes schools kind of give that impression of what a workplace might be like. But to see you guys kind of like, willingly step into a space where you trust your creative instincts and collaborate together to create something that hadn't existed before was really impressive. And I just wanted to give thanks and appreciation for that.
Yes, thank you. I always like to ask, what surprised you? So you took a leap of faith. This is a 8-week working from home or working remote experience. Is anyone willing to share what surprised you about this experience that maybe you didn't share during your showcase presentation?
I'd like to say something.
Please.
What I'd like to say surprised me was normally I'm not best when it comes to communicating with new people. Once I get to know somebody, I'm really talkative and I can talk for hours, but when first meeting somebody, it's kind of hard for me because like I have no way to relate to them, and it's just hard for me to be able to talk to new people. But what surprised me was I was able to talk to Andrew and some of my coworkers, and I kind of grew a bit of a relationship somewhat like that. So I was able to talk to them more freely, and I wasn't as nervous talking to them. So, yeah.
Thank you. Thanks for sharing, Emilio. Anyone else want to share?
I can share something.
Thank you.
I thought it was like really awesome how my team like collaborated, even though we were like over Zoom. Like at first it was like a little bit rough, but like once we like really got into it, we got into like our breakout rooms and then like we immediately started working, we immediately started like collaborating on stuff. So that was really cool to see, even though we were like not in person, we still like collaborated a lot.
Thank you. Thanks, Rosalie, for sharing. How about you, Jana?
I found it interesting how like it was interesting to like learn more about the soil monitor because at first I didn't want to do that. I want to do something else. But as we got into it, like as a team and like did the project itself, it was very interesting to learn more about it and how it was actually needed more than anything else. And like I wanted to do like the skate group. I think they did really good, and that was like really interesting to me. But I think it also benefited me to learn more about different fields.
Thank you. I love hearing these different. One more person. Could you share what surprised you?
I'd like to add something. So I was actually really happy to see what my teammates have been working on, like everyone in our engineering group, because it was so interesting to see how they came up with all this stuff, they made it, they printed it, and they had like this whole idea for it. It was really cool. And me myself, I'm not really that knowledgeable in terms of engineering. I did not expect to have a product myself, but it was really fun, and I had a fun time creating something.
Are you gonna bring, is anyone gonna be able to bring any of these to the celebrations for us to see in person? I'm just curious. Is that something? I don't know how big they are. I don't know if there's anything, Andrew, you think we could show at the showcase at the celebrations?
Yeah, absolutely. I know this skate group did some stuff. I mean, every group had viable products. They were just at different points in the production of them, given the different projects that they were working on. I've been 3D printing some things, and I know the different camera groups had, were interested in having like a finished product. And so I'm excited to kind of get those files printed out, and hopefully we have to have something for the next step of in the product development process of having something tangible to look at.
Awesome. Awesome. Michael, please, what would you like to share?
We had some technical issues for our presentation. Would it be okay if we could finish off?
Yes, I would love for you to finish up, please.
Thank you so much.
Yes, thank you.
As we mentioned before, our next step would be actually to build our soil monitor and test it out and complete the housing for it. But we would like to give a thanks to our deep dive lead, Andrew, for always providing us with help, and to Bayha Group for giving us this opportunity to learn. And thank you all for listening to our presentation.
Thank you. Yeah, it's really great to see what you all could do. And so for everyone watching, we've had over 230 high school apprentices this summer, and they've been divided into deep dives, 9 of them. And so we are showcasing, we have another showcase later today. It is in about an hour and a half. It is it's actually Andrew's colleague Brian's group, and they are going to talk about environmental restoration. And so that someone help me
It's
with
at 1:30.
Thank you, Sandy. It's at 1:30. And so we hope that you'll join us then. Amelia, do you have another comment?
Yes. So how long have you guys been doing the Bayha company, like going to schools and working with kids? I was wondering.
Oh, it's almost 10 years. So what district are you in, Emilio?
Oh, I'm from Downey.
From Downey. So Downey is near and dear to my heart. So I'm always saying that there would be no Bayha Group without Downey Unified. And that is definitely, I'm very grateful to Downey Unified. So Bayha Group has been working with Downey Unified since 2015. Since 2016, we've been doing, we started with in-person internships. So pre-pandemic, they were in person. And students got placed in different local businesses in Downey and had summer internships. It's evolved to become, because in 2020 we transitioned to remote, working from home. I've been working from home for over 20 years. So when COVID-19 happened, it was not a big change for my team and me because we've been working from our homes for a number of years. And so the district allowed us to work with all of you remote. And so it just allows us to have a broader array of who could be deep dive leads. Some of them are based on the East Coast. We have one in Maryland, one who is based in New York. We have coworkers who are based in Georgia. And so it allows us to have a range of people. Sandy's actually from London, so it allows us to work with a wide range of folks from around the world, and to give you an experience where sometimes some of you have been traveling, so and had continued to participate. We know some folks have been on some family vacations and still can participate in the apprenticeship. We know some folks might even have another job, and because this is remote, we're able to have the ability to work with you in a more flexible environment. So to answer your question, we're very excited. We're gonna approach our 10th year next year with Bea Group, and in providing these kinds of opportunities. What we do is we work with the school districts with regard to securing some funding through state grants, and then we're able to leverage the grants to provide these opportunities. So we're very, very grateful to the district communities. We work with Downey Unified, with Davis Joint Unified, with Glendale Unified, and so yeah. So thanks for that question. Does anyone else want to share anything before we say goodbye? Anyone? I see some district representatives. Anyone want to say anything?
I think
Go ahead.
that like by me going over this apprenticeship and seeing everyone go through the apprenticeship themselves and see like how they grow and like how helpful it is. It's just like I love it. Like I can see firsthand the change that it can do in youth from like starting from young. And a lot of you may not see what's gonna do in your life, but after the years I've realized like how good it was and how helpful it was, how it has helped me in my life.
Okay, hold on one. You have to explain who you are and what your relationship with this program is, because it's out of context.
Yes. So let's start again. I was an apprentice 2020. I think 2020 is summer intern at Bea Group. I'm from Warren. I graduated. No, I did not graduate from Warren, but I was going to Warren when I was in my junior year. When COVID hit, like we were gonna have the MAID program, the normal MAID program in person, and then everything was online. And so I was one of the first batch of people that did the program online, and I loved it. And it was actually great also because then I moved to Georgia where I graduated, and I still was still connected with Bea Group, and now I'm working with Bea Group because I want to help this program like change youth's life, like how it changed mine. And I just think that like it changes youth's life. It's so helpful.
Thank you, Juan. All right. Anyone else want to say anything before we say goodbye? And don't leave, apprentices. We're gonna take a photo on after and have a couple comments. So if there's nothing else, I'm gonna turn off the live stream and hope that you all come back for the second one today. And then we have 2 more tomorrow, Wednesday, and then 4 of them on Thursday. So there's a lot more content, a lot more apprentices sharing what they have gone through this summer. So let's see. Okay. All right. I'm going to say goodbye. Everybody good with that? So bye. We'll see you in an hour.
Question.
Oh, yes. Wait, I haven't said bye yet. You want me to say bye first, Chris, before you ask the question?
Go ahead.
Let me end the recording. Okay. Let me end the live.